Hello, this is Ian's son, Greenberg, Physics C, Period 2. I'm doing Chapter 15, Number 1. Number 1. A ball dropped from a height of 4 meters makes an elastic collision with the ground, assuming no mechanical energy is lost due to air resistance. Show that the ensuing motion is periodic and determine the period of the motion. Is the motion simple harmonic? Explain. So, we're taking a 4-meter ball and we're dropping it. The first question is it periodic motion? The key word here is that no mechanical energy is lost. So there's no energy lost, that it remains constant energy. So you have a high amount of potential energy at 4 meters high, and you have a bunch of kinetic energy when it hits the grounds. I said it's periodic. This is because no mechanical energy is lost, so the ball will always have enough energy to return to its original height. So the ball essentially is going to go in a motion from 4 meters to the ground forever because no mechanical energy is lost. So it's constantly bouncing up and down, returning to its original height, coming back down, returning to its original height. So that's periodic motion. Part B of the question asks, what's part B of the question? Determine the period of the motion. So basically a period is how long the ball takes to come down and then come back up to return to its original place. So I'm going to calculate how long it takes for the ball to fall, and then that time is equal to the amount of time it takes for it to come back up. So I'm going to use a kinematic. X equals VIT plus half AT squared. There's no initial velocity. So X is 4 meters equals half. A is gravity, 9.8 meters per second squared, and then t squared is what we're solving for. So the time that we solve for is 0.9 seconds if you solve that down. And then remember, that's how long it takes for the ball to fall. A period is how long it takes for it to fall and go back up, so we have to double that. So t equals 2t equals 1.8 seconds. So that's the period, 1.8 seconds. So it asks if it's simple harmonic motion. It is not simple harmonic motion. How I think of simple harmonic motion is that you have a spring, and then the spring in the middle, it has the highest amount of potential energy at a rightmost point and a leftmost point. The properties of that would be that from this equilibrium point, it increases to the potential energy at the right and the potential energy to the left. The reason why I say this certain motion isn't periodic, isn't simple harmonic, is because that it is falling at a constant force of mg. It's falling at the constant force, and at the middle, which if you had an equilibrium point, the potential energy here and the potential energy here is different. So if you recall from the class, you would remember that the highest amount of potential energy is at the top, is at the furthest most point, and the furthest most point, and at the middle, you have the highest amount of kinetic energy. That's not true for a ball falling. The highest amount of kinetic energy is at the bottom. So that's why I thought simple harmonic motion. Okay, awesome. Thank you.